Hello everybody. Today I'm going to explain and demonstrate what is an equalization filter. Well, so far in the filter series we have discussed about low pass filter, high pass filter, band stop, band pass, notch, and all pass filter. Well, an equalization filter is no different from all the filters that we have discussed so far. It is just a customized filter that incorporates all the filters that we have discussed so far. So what is equalization? Equalization, or EQ, is the process of adjusting the balance between different frequency components within an electronic signal. It is one of the most useful processes in music production, definitely plays a great role in audio mixing, and it alters the frequency response of an audio system. Let's discuss about this more in detail. Alright, now that we know what equalization is, what is an equalizer? Well, an equalizer is a circuit or equipment used to achieve the equalization process. An equalizer is a collection of filters that influence the volume of specific frequencies or range of frequencies within the human hearing range, which is of the audio spectrum. The human hearing range is from 20 Hz to 20 kHz. So an equalizer is also referred to as a frequency-dependent volume knob. So, it is so flexible that it can, increase the presence of certain frequencies which are really required, and you can decrease the presence of certain frequencies which are not required at all. Alright, there are different types of EQ filters available to perform the equalization operation. So there are types such as graphic EQ, parametric EQ, semi-parametric EQ, peak EQ, and programmable EQ. But today we'll discuss two major types, which are graphic EQ and parametric EQ. Alright, let's talk about graphic EQ. Now remember, the goal of any EQ is to control what frequencies are let out and what frequencies aren't. Now, graphic EQ achieves the same thing by using a bank of evenly spaced slider controls. We'll look at how a graphic EQ filter looks like in a bit. Now, different types of filters have different numbers of frequency bands, but in general, the greater the number of bands, higher is the accuracy over the frequency spectrum. If you have lesser number of frequency bands, you might have to compromise on the accuracy of, boosting or attenuating a particular frequency or range of frequencies. Now, graphic EQ with a narrower bandwidth has greater precision than the one with a wider bandwidth. But in general, graphic EQ only offers a basic control, which is to adjust the gain of frequency bands. So, meaning it'll just help you in attenuating or boosting a frequency, a particular frequency or range of frequencies. Graphic EQ offers basic control of adjusting the gain of frequencies or range of frequencies. However, it doesn't offer any control over the filter shape or the bandwidth of each band. It is thus useful for making small incremental adjustments across the frequency spectrum for obtaining smooth results. However, it's not suitable for fine-tuning of frequency response or surgical level work, which is often the case for professional audio editing and audio mixing, which is where the parametric EQ comes into play. Let's talk about that. Alright, here's a graphic EQ filter. In fact, it's a 31 band graphic EQ filter with two parameters to control. One is at the bottom, which is a frequency, a 31 band frequency, and one on the right, which is a gain control. So graphic EQ allows tweaking these two parameters to obtain the filtering. It is useful for making small incremental changes across the entire frequency spectrum. However, it's not useful for making drastic or sudden changes. And that's where the parametric EQ comes into play, which is very useful for professional level audio editing or audio mixing. In this example, I've used the graphic EQ to do some changes, to change the frequency spectrum. So I've applied a bass cut filter below 100 Hz. Then I've boosted the frequencies in the range 300 to 2000 Hz and also some range in the treble region. Let's talk about parametric EQ. They're the most common and versatile type of EQ used in music production. They offer configurable and adjustable frequency bands. In addition to the level, they can also control the center frequency and bandwidth of each frequencies with highest precision, as compared to a graphic EQ, which can only control the level and the frequency. Alright, here's an example of a parametric EQ. In fact, it's a 7-band parametric EQ available in Pro Tools. So as you can observe the picture, you can see a hell lot of knobs, and it offers more flexibility and features compared to a graphic EQ. Let's discuss about different features offered by parametric EQ in detail. Alright, the first filter parameter of a parametric EQ filter is frequency. Now this parameter adjusts the center frequency range for each selected band. It also sets the frequency cutoff point for low and high cut filters. So as you can observe here, the entire human hearing range from 20 Hz to 20 kHz has been split into 5 different frequency bands. And they are the low frequency, the mid frequency, the low mids, the mid frequency, the high mids, and the high frequency. Now here we are free to choose the center frequency of each of these frequency bands. So for example, for low frequency I have chosen 103.9 Hz as a center frequency. And then for mid frequency as 1.12 kHz and so on. So all we have done in this is just set the center frequency of where we need to perform a particular operation. For example, if you want to perform a low pass, we just input the frequency and then comes the next step. Alright, the second parameter is about resonance or Q factor. In the first parameter, we chose the center frequencies for each of these frequency bands. In this parameter, we're going to adjust the bandwidth of those selected frequency bands. So basically, it determines how wide or how narrow the boost or cut frequencies have to be. So greater the Q value, narrower is the range of frequencies to be accepted or rejected. And lower the Q value, it offers wider range of frequencies, greater the frequencies accepted or rejected. So as you can observe here, there are the same 5 frequency bands: low frequency, low mids, mids, and high frequency. And these are the values of the Q factor. So if you observe closely, I've put the value of 1 for all the frequency bands except for the mid frequency, where I've chose 1.14, which means the mid frequency is going to be, more narrower in terms of accepting or rejecting frequencies. Alright, the third filter parameter is gain. So this parameter decides whether we have to boost a particular band of frequencies or attenuate a band of frequencies. Now that all depends on the gain value. If the gain value is positive, which means that the band of frequencies will be boosted. And if it's negative, it means it's going to be attenuated. So if you look at the picture carefully, the bottom line represents the gain. So, I don't know if you can see the values, but surely you can see the knobs. So, the knobs are pointing way down here at the low frequency and the high frequency, and they're negative and, minus 6.8 and minus 7.2 dB, whereas the low mids, the mids, and the highs, they are positive, which means they're going to be boosted, whereas the low frequency and high frequency, they're going to be attenuated. Alright, the fourth filter parameter is the filter slope. So it sets the steepness of the filter. So it's like, how much attenuation or boosting you really require, how quickly you require it. Okay, so if you observe the previous videos, we would have talked about windowing and the transition from the pass band to stop band in case of band pass and band stop filters. So greater the slope, the quicker the transition, and sharper the filter. More close it is to becoming an ideal filter. So the slope varies from 6 decibel to 96 decibel per octave, and it's available in the setting. You can alter it as per your requirement. Alright, the fifth and the final parameter is the filter type. So this parameter allows you to choose a filter shape for a selected frequency band. The available filter types are the same ones: the low cut, high cut, band pass, band stop, and notch. However, there are different filters such as a low shelf and high shelf filter. Now we'll discuss about these types in a later video, but to give you a heads up, a low shelf filter is one that has a cutoff frequency and it accepts or boosts anything below the cutoff frequency, but doesn't necessarily eliminate frequencies above the cutoff, unlike a low pass filter, which just eliminates everything above a cutoff and passes everything below the cutoff. So same goes for high shelf filter. Alright, now comes the fun part of demonstration of these filters. So for the purpose of demonstration, I'll be using a royalty-free music. First, the music will be played as is, then a graphic EQ filter will be applied to the music, and finally a parametric EQ filter will be applied. For convenience, I'll be displaying the graphic EQ filter and parametric EQ filter when the relevant music files will be played. Alright, I hope you heard the music files and were able to perceive the difference. Now let's talk about applications. So EQ is used to remove problematic frequencies, enhance musical frequencies, balance various elements in the mix, and shape sounds in creative ways. They're used to achieve clarity, depth, presence, tonal balance, and tonal reshaping in a mix. However, they have to be performed meticulously, as altering the frequency response is like altering the timbre or the sound quality, and it'll just distort the tone and the harmonic makeup. So use it with care. Alright, we have seen about graphic and parametric EQ. What we can conclude about them is that graphic EQ is easy to use, but can only make broad changes to the overall mix. It is not as flexible to use as a parametric EQ, whereas the parametric EQ, on the other hand, requires some expertise to use, but can provide some specific compensation or alteration around a chosen frequency. They can be used to perform surgical level work, which is often the case in professional audio editing or audio mixing. Alright, thank you for watching this video. I hope you enjoyed it. If you have any questions in the comments, I'll be sure to respond. Alright, thanks a lot and have a great day.